Welcome to the Pacific Northwest Geodesign Forum. I'm Tim Nyergis, Professor of Geography and Director of the Masters of GIS for Sustainability Management. I'd like to take this opportunity this morning for thanking you all for signing up, registering, being here this morning at this early hour. Hopefully a number of other people will arrive in due time, as it would be. And I'd like to take this opportunity to acknowledge the sponsors of the activity. This event wouldn't occur, at least the students, for there is a free lunch in the world every now and again for students. Students didn't have to pay a registration fee. So the 4 colleges from the University of Washington came together, or at least units, I should say, from 4 colleges came together. The College of Arts and Sciences, with the Department of Geography and the Division of Social Sciences, the Master of GIS Program for Sustainability Management within the Department of Geography. From the College of Built Environments, we have Landscape Architecture and Urban Design and Planning that are part of the Planning Committee. From the College of Engineering, we have Civil and Environmental Engineering. And as engineers, sometimes, as it would be, I'm a geographer, a would-be engineer, as the case would be, I think, all these years. The engineers sometimes have a little bit deeper pockets. They didn't even want to bother to go to their dean for money because they had enough to contribute themselves. So that was quite nice for the faculty to get together and do that. From the College of the Environment, we have the School of Environmental and Forest Sciences. And last but not least, the National Science Foundation funded project. It's called the Cyber GIS Project. It goes by the formal title of Software Integration for Sustained Geospatial Innovation.
Okay, our next presenter is John Sharrard with Esri. John is a solutions engineer and currently works with the Olympia Regional Office. And he graduated from Oregon State University with a degree in geography. John has been with ESRI for 20 years. Prior to joining Esri, he was a senior GIS analyst for the state of Oregon for 7 years. And so today John's going to bring us modeling urban environments with City Engine.
Nope, just It's nice to be here today, see some former colleagues that I've worked with at Esri over the years, and to see a crowd that's interested in geodesign. So one aspect I'm going to talk about today is some actual tools. In this case, we're going to be focusing on City Engine. It's a bit of a challenge to try to do this in 15 minutes. I'm going to give you a quick run through on the basic ideas behind City Engine and kind of where we're going, where Esri's going with the technology. So City Engine is a desktop application, so you install it on your system. This is part of the ArcGIS platform. So if you're familiar with ArcGIS Desktop or ArcGIS Server or ArcGIS Online, how many folks here actively use those technology? Okay, fair amount of you. This is one part of the platform. This is focused on designing or providing tools to develop scenes in an urban environment. So you can go kind of crazy and build things that may be a little nuts, but you certainly can build some very realistic scenes and do a significant amount of analysis with the technology. City Engine is all about procedural modeling. So what this talk is about is taking inputs, simple geometries, and quickly rendering those in a complete scene, in a three-dimensional scene. So the way we do this is we start with a base geometry. And in most of the examples I'm showing here today, I'm talking about buildings, but this also works for street furniture, vegetation, and other things that would complete the scene. But in this case here, we're going to be working with footprints or lot lines. We're going to be applying rules to them. These are the procedural rules, and this is really the magic behind City Engine. So I'll expand this a little bit. This is called a shape tree. This is essentially how we take our simple geometry and apply functions to that to generate the completed, in this case, of building. But we'll talk more about what's behind the shape tree and what the rules are a little bit more detail later. But what we end up with is a process where we're starting with simple geometry, we're applying some rules to break it into different components of the building in this case, and we can iteratively alter the rules to get a more realistic model at the end of the process. So why do we want to do this? Well, for any of you who have developed 3D scenes, the traditional way to do this is by handcrafting individual building models, which can be a very laborious process. My own experience with this is building models for the Esri office in Olympia, Washington took me 2 or 3 days for one building. So it's not a very productive way of creating scenes quickly. But by applying procedural and modeling techniques, we can greatly increase the speed of developing these scenes. Now, there is a part of this workflow for procedural modeling where you have to build the rule sets that are applied to the geometries to create the finished models. And that you have to invest time in that. It's becoming much easier to do. But there's some point where it's more efficient to adopt procedural modeling rather than handcrafting. So the process from a GIS standpoint, if you're an existing GIS user, is you're working with existing geometries. So in this case, we've got a screenshot from ArcMap where we've got some building footprints, and I know it's very difficult to see, but there's also vegetation and street furniture geometries. So these are simple, mostly 2D geometries. There may be some of those geometries that say the buildings that have the height of the building as part of the attributes. Attributes are a big part of making the procedural modeling work. So if you have attributes that describe something about those geometries, so in the case of building footprints, perhaps we've got how many floors there are, how tall it is, or if you would think about vegetation, maybe what kind of vegetation. Is it a shrub, is it a tree, and so on and so forth, could all be described in the attributes. And when we have those geometries and the attributes, we apply those to the rule package. And what we end up from that is the creation of a finished scene. It's not all that quick and easy to do, just like this, but you're usually going through an iterative process where you're adjusting the model as you go forward. Once you have the model, you can go back and change individual pieces of the model. So here with parametric editing, and the shot on the left here, we've got a building. You can go into, select the building and say, I want to add a floor to it, or I want to change the roof to it. So by just changing values in that individual model, you can quickly render it in a different way. Or perhaps maybe you want to do dynamic editing, so you want to use your mouse and be able to drag it to a different location, drag the building to a different location, or maybe pull one corner out. That's a dynamic editing environment that this supports as well. Then more towards the analysis side of things is that you can, as you make changes to the models, you can have it change some of the reporting possibilities. So for instance, if you wanted to add an extra floor to a building, what does that do to the available floor space? Or what happens if you add that floor? Does it change the electrical requirements and so on and so forth? All of that can be built into the model in its reporting tools. So let's talk about CGA rules. So this little introductory slide here, it basically illustrates the process that I'm going to go in a little bit more detail with. So we're starting with the simple geometry. And like I said earlier, you can go kind of crazy on the buildings you build. It's up to you. So CGA stands for Computer Generated Architecture. So this is the underlying language behind the system. I'm not going to get into great detail about the spot on the left there, or the section on the left there that gets into the actual what does a CGA rule look like. For the most part, as an end user, you're probably not going to spend a lot of time dealing with the rule sets. But for purposes of explaining how it works and how it does this, we're going to go through a little quick demonstration here. We've got a footprint here on the right. We're going to apply a simple rule to it to extrude that into a block. So you can see up there on the left it's highlighted. There's the extrude function with a value of 10 in there, which in this case is probably on the order of meters. So it's that 10 value may have come out of the attributes that were carried with the simple geometry. So we have that block, but we want to break that into components. So if you look at this box that's sitting there, there's 6 sides, one of which is hidden, but there are 5 sides around it, the 4 sides here plus the roof, that we can individually deal with here. So as we step through these expanding the CGA rule, we're adding more and more detail to it. So we took the roof and we said, well, we're going to put a hip roof on it. So that's the essence of how this works. Now, like I said earlier, typically you're not going to want to work with this raw CGA script on the left. You're going to want to work with some of the parameters that have been exposed. So this screenshot here on the right is from the user interface. And you can see that the 2 attributes, height and angle, are actually presented to you in the interface as slider controls. So you can go in here and go away from the default and change a particular building's height or its angle. So here's a little bit more summary. But basically, to get to this point, we're stepping through those rules there on the left, and that's the resulting shape tree. So there's a visual representation of the actual rule. So let's take this beyond what single building into multiple buildings. So here we've got lots, and we have streets here. And we're going to start applying some rules to it. So we went and do the extrusion here. We'll do a setback from the road. We'll break each of those individual pieces up into offset into individual parcels. And we'll apply some texturing onto it. The texturing is a bit interesting here. Here we've got a side of a building, and it's been divided into floors, and then horizontally it's been divided into different sections. And to each of those sections we apply some sort of image texture file onto it. So the end result is we're putting perhaps a real picture of a window in the spot where a window would be on the model. As you expand the model dynamically or through changing height attribute, it's going to replicate that particular part of the facade throughout the building. As we talked about earlier about the reporting ability, here's just kind of a screenshot showing that we can deal with the individual floors. We've got some report defined for it for gross floor area. Now, most of the examples that I've seen in our user community is actually a mix of these procedural models often with an as-built model. A lot of what we see with CityEngine is people developing what-if scenarios around some particular city block of interest or building of interest, where they may have an actual model that they've imported out of something like SketchUp or AutoCAD. So I will see a mix in CityEngine of the procedural models as well as the as-built models. In terms of the workflow, going back between traditional ArcGIS Desktop and City Engine is that you can read and write interactively into a geodatabase with City Engine. We also provide a lot of the design tools for, we talked about gross floor area, density. If you change those parameters, you can change the resulting model. So here on the right, we've increased the density in this particular city block, and it changes the generation of the procedural models. I'm going to show a little bit about this later. This is exporting into a web environment the work that you've done inside City Engine. I've got an example here in a little bit. And just a few things about City Engine. What's going on right now is we have added additional libraries for supporting your work. So there are now vegetation libraries that you can work with. These are essentially rule sets, things to support zoning and general buildings. A new thing I want to point out is the 3D Cities Information Model. This is a new environment for, or a new schema that you can use. It's available now for building your buildings and also your legal environments surrounding them. And I'll give a little quick slides of these because I know we're running out of time. I've already talked about the buildings. We also, part of this model is modeling the building interior, as well as other supporting structures like fire hydrants, bike racks, things like that, and also water, sewer, stormwater, those other things that would be part of a model. And also the legal environment. So here we're talking about zoning, and we're talking about the parcels. All of these things are part of the city information model. And also typical land cover built things. So here we're showing geology and wind, weather, and atmosphere. So this is a big year for 3D from Esri. We're doing a lot of work on extending our technology to support additional platforms. Certainly mobile, which has now become the dominant way that people get information from the internet, is a big player in our solutions. So we're working on ArcGIS Pro, which is sort of the next generation of the desktop technology. It's currently in beta. It will be available later this year. This will be come to you as another application in the ArcGIS desktop install. So you might be familiar with ArcMap and ArcCatalog. There's this new one on the horizon here that you'll have access to pretty soon. We're also, in that vein, the new ArcGIS Pro is now 2-dimensional and 3-dimensional. So you'll be able to work in those environments with multiple maps and 3D all at the same time. I'm going to put together a list of resources. There's some excellent videos that, if you're interested in this, I'll steer you to. So I think I'm going to skip ahead here because I do want to show an actual demonstration here. So let me go ahead and bring this up. And what we're looking at here, I'm going to go ahead and let it play. This is a web scene that's generated inside of City Engine. What you're looking at is not a video. This is an actual City Engine. It's a compressed file that's been downloaded into the browser that you can interact with. Right now, it's jumping to different viewpoints through the city of Portland. We'll point out that Portland is sort of one of Esri's key cities for helping us to develop this technology and represent it. So I'm going to jump to a couple things here. We're going to go to the Chandler building, stop playing, and I'll show you that I can interact with it. So if I go poke on this and I click on the building, I get information about that particular building. If we go here and I can go and expose the interior of this building, and I can interact with the individual rooms inside the building as well. This scene, as well as many others, are available online from, if you go to the City Engine resource pages, you'll see these in the gallery. They do require some of the more modern browsers to work with, so it's supported in Firefox and Chrome and Safari, and I think in the latest builds of Internet Explorer as well. Now, what I can't show you right now is in this particular scene off of the web is it does have access to some webcams. So the states, there's a little shot right there. So if you go click on this off the actual web-fed scene rather than one that I have loaded on here, you'll get connected to the Department of Transportation's highway camera system with it. So with that, I'm out of time and be available to answer questions. Oh, one thing I forgot that I have to show, because I know we put a lot of effort into this, is I have data from the folks. Cyber City helped us out. I was asked to step in to do this presentation kind of late last week, and we asked Cyber City to give us some of their work that they've done inside City Engine. This is actually data from the University of Washington, screenshots of that. So this looks like these buildings here have been selected based on a buffer around transit tunnels. So is there, I'm not familiar with what's going on up here, but are they talking about putting transit tunnels in here? Okay. Yep.
Okay, great. Thank you.